We can use the heat produced in a nuclear reactor to generate electricity. Let's work backwards in this schematic diagram. The most common way to generate electricity is to spin coils of wire very fast near magnets. It doesn't matter if you spin the coils or spin the magnets, the effect is the same. A voltage is produced across the ends of each coil, and indirectly it's this voltage that allows all our fridges, TVs and mobile phone chargers to work. A big generator in a power station may support the electrical needs of 50,000 people. Think of trying to spin 50,000 washing machines all at the same time, and it gives you some idea of why the forces needed to keep the generator spinning are huge. To cause the spinning, you blast superheated high-pressure steam through a turbine. The turbine design is very complex, and you can't see it moving because it's enclosed in heavy casing to keep the steam in. The steam isn't like the clouds you see when you're cooking. It's pressurized to about 45 atmospheres, heated to 500 degrees Celsius, and screams through the turbine at upwards of 1,000 kilometers per hour. Think of being near a big jet engine if you want an idea of the sensation. To shift energy quickly enough to run all those electrical appliances, you need to boil about a ton of liquid water per second completely away into superheated high-pressure steam, and this requires a lot of heat. Some power stations still use powdered coal, but it's much cleaner to use a nuclear reactor. A nuclear reactor in a power plant is like a big kettle heated by metal rods that get hot all by themselves. Inside the metal rods are little uranium fuel pellets, and it's the nuclear reactions that happen in the fuel pellets that cause the heating. Each pellet can provide enough heat to generate electricity for a person for about a year. Typically, you pass high-pressure water through the reactor and use that water to turn the water that passes through the turbine into high-pressure steam. And this means the turbine side is isolated from the nuclear side. The water that passes through the reactor is sometimes called a coolant, but this name is a bit misleading. It's a throwback to when scientists built the first experimental reactors, and they simply passed water through them to keep everything cool. In modern reactors, the water isn't there to cool the reactor, but to do the crucial job of moving heat from the reactor core to the boiler. Some reactors are designed to use carbon dioxide gas or molten metal to shift heat around, but the pressurized water reactor is by far the most common.